Right, let's get into it. We're going to pull apart a GCSE chemistry question to show you precisely how to lock in every single mark.
Okay, so we're diving straight in with question 2. This one's all about acids, alkalis, and a titration experiment. It's a classic topic, and trust me, by the end of this, you'll know exactly what the examiners are looking for to get those top marks.
So here's how we're going to break this down. First, we'll knock out the quickfire questions. Then we'll look at how to read the equipment properly. After that, we'll tackle the big 6-marker on the method. And finally, we'll pull it all together. Okay, first up, questions 02.1 and 02.2. These are your bread and butter questions, the ones you really want to lock in right at the start to build some momentum. So, question 1. It's a multiple choice, just 1 mark up for grabs. This is a pure test of your fundamental chemistry knowledge. And boom, there it is, straight from the mark scheme, H+. All acids release hydrogen ions when they're in a water-based solution. Simple as that. That's 1 mark in the bank already. All right, next up we've got a word equation. This one's worth 2 marks. They give you part of the equation, and you've got to figure out the missing acid and the other product. So you get 1 mark for figuring out it's hydrochloric acid, and another for knowing that water is produced. Just remember that classic rule. A metal hydroxide plus an acid always gives you a salt and water. Now, this is a really great tip, straight from the mark scheme itself. They're flexible. If you're confident with your formulas, go ahead and write HCl and H2O. You'll get the exact same marks, so you can use whichever you're more comfortable with. Okay, moving on. This next bit is all about your practical skills. It tests whether you can actually recognize and read the kind of equipment you'd be using in a real lab. So here's the diagram we're working with. Figure 2. It's a standard titration setup, and the next couple of questions are all about what you see right here. Super straightforward question here for 1 mark. What is this piece of kit called? You know, the long glass tube with the numbers and the little tap on the bottom? And the answer is a burette. Now listen up, because this is important. Spelling counts here. The mark scheme is super clear. They will not accept biuret. That's a totally different thing. 1 wrong letter and you lose the mark. Okay, so what's the reading? You've got to look really closely at that zoomed in bit. Pay attention to where the bottom of the meniscus, that little curve in the liquid, is sitting on the scale. The correct reading here is 27.6 cubic centimeters. Remember, with a burette, the scale goes downwards from the top. The mark scheme will also take 27.60, but you absolutely don't need it for the mark. 27.6 is perfect. Right, here we go. The big one, the 6 marker. This is where you really get to show off. It's your chance to prove you don't just know the facts, you actually understand the whole experimental process. So the question is asking you to describe a method. And to get all 6 marks, you need a plan that's not just clear and logical, but one that would actually work if you did it for real in a lab. So at its heart, this is the method you need. You've got these 6 key steps. Get them down in a logical order, and you are well on your way to those top marks. This is your foundation. But, to really push into that top band, you need the details. This is what separates a decent answer from a fantastic one. Mentioning a pipette for accuracy, a white tile to see the color change, swirling the flask, adding drop by drop near the end. These little things show the examiner you're thinking like a real scientist. And don't forget this last bit. It's absolutely crucial. You have to explain what your results actually mean. It's no good just doing the experiment. You have to say, hey, the acid that needed more sodium hydroxide to neutralize it, that's the more concentrated one. You have to make that link. Okay, so let's wrap this up. What's the big takeaway here? What are the examiners really looking for when they're marking this question? Think of it like this. You've got to use the right scientific words. You need to know your basic reactions. You have to read your equipment properly. You need to lay out your method step by step. And you should always throw in those extra details about accuracy and reliability. And of course, finish with a clear conclusion. And there you have it. That is how you break down question 2 and make sure you walk away with every single one of those marks. See, the mark scheme isn't some big secret. It's literally a roadmap to the perfect answer. And now you know how to read it.